Hi, in this longer lesson we are going to work with validation layers. Validation layers are Vulkan's way of communicating with the developer. You can subscribe to different validation messages, which will help you debug or make the best decisions about your application. We're going to use them to make sure that we don't make any mistakes throughout the course. Otherwise, you can disable validation layers on release builds, since they might hinder performance. First, we will need a validation-enabled Boolean member. And here in the constructor, we're going to set the validation enabled to true if we're not building in a release mode. And I very quickly rename the member to have an underscore at the end. So now to enable validation layer, we will need to request the validation extension. Currently, we're only requesting the surface extensions that the GOFW wants. So I go to the header file and I add a new method that is now called getRequiredInstanceExtensions. This method will return a vector instead of a spandau, and I quickly copy the signature so that I create it in the source file. I find a place here and paste the new method. Now I will cut this code here, since we will replace it with a call to our new method. And I will initialize a new variable with the result of this function call. I also need to replace these values here to use the new variable, of course. And I go below and paste the code that I copied from the createInstance method. Now, here I will create a new vector that will be initialized with the values of the suggested extensions. I use the stdcopy to copy the values from the begin to end into the required extensions vector. And after that, we want to test the required extensions. Between that though, we want to check if we're doing validation. We can't access the validation enabled member since we initially made this function static, which I will now correct. And when I return, we can now push back this vk-ext debug-utils extension name. And lastly, we return the required extensions. Now we need to check the supported layers. This is very similar to checking the supported Vulkan extensions. So I go into the graphics header and duplicate the line for getting the supported instance extensions. I rename it to get supported validation layers and it returns vk layer properties. We will also want this method for checking if all the requested validation layers are actually supported by Vulkan. Now I copy the signatures of both of these methods and go on into implementing them. I paste them in the implementation file and give them bodies. Here I will also copy a lot of the code from above. Since the type of vk layer properties is a bit different, I will have to duplicate these functions as well and rename the extension to layer wherever I see it. Here the extension name is actually layer name and so on until all the places are replaced. Whenever you see this window pop up, I am using the F2 shortcut to refactor the name of a variable or function. Now that we've refactored this part, we also want to implement the getSupported validation layers. Again, this is very easy to check and we will copy the code for getting the extension properties. The only difference here is that this function doesn't take a first no argument. Now here, where we create the instance, we can choose to request validation layers. I create a new array of a single string and inside it I put vk layer chronos validation. You can also add advanced validation layers if you wish more detailed messages later on. Then I will check if this layer is supported by calling RO layers supported. And I will also rename this parameter here to layers for consistencies. If they are not supported, we don't want to exit this time. We just want to disable the validation. Now, here at the instance creation info, we want to also request the validation layers. Previously, we set this value to 0, but now we want to enable validation. So I add a check if validation is enabled. If it is, now we keep the code where we don't set any layers. Otherwise, we will set the layer count to the validation layer size and the pp enabled layer names to the validation layer's data. Now that we requested the validation layers, we will need a messenger. The messenger will be the thing that receives any validation messages and decides what to do with them. I will start by including IOStream since we are going to print out messages to cout. Then we need to use a very special signature to create a messenger function. First we need a vk API attr for attribute, then vk bool32, and finally vk API call. Then we can name our function freely. I call it validation callback. And we need these parameters. vk debugUtils message severity flag bit, vk debugUtils message type flag bit, vk debugUtils messenger callback data, and finally a void pointer. Inside the body of the messenger function, what I will do is output the validation message. It can be taken from the callback data. And I return vk false at the end of this function. A small correction here I have written using instead of static. In here, we can also check for severity of the message. You can have infos, warnings, errors, and others. These are also gradually higher numbers, so we can have an if check. If it is a warning or above, we can output to the console error and to cout otherwise. Now that we have this function, we would like to tell Vulkan to use it. We can do that by creating a messenger. So I add a new function called createMessenger. This function will not actually create the messenger, but we will populate the info object for it. You already know how info objects work from when we created the instance. Here you will notice that the info object is called vkdebugUtils messenger createInfo ext. The ext at the end indicates that the object is coming from a Vulkan extension. We enabled the extension earlier, so I'm just pointing out the standard notation here. You also notice some structs might end with khr for Chronos. This is usually notation used for official extension by Chronos. Chronos is the organization behind Vulkan. Actually, since this function is already just initializing the creation info, let's rename it to getCreateMessengerInfo. We can now specify the severity of messages that we're interested in. I will copy the warning bit from here. This is a typical bitset type of field, so we can select the different bits that we want to enable. So I put a bit or operation and add severity error as well as the verbose bit. Now the next field that we need to initialize is the messenger type. We're only going to subscribe to general messages and validation messages. These will report the most typical Vulkan errors. Finally, we need to select the function to be called. This is a pointer to a function. This is why it's prefixed with pfn. So for the user callback, we set the validation callback that we created earlier. And finally, we can also add a pointer to some custom data. If we had this function be in an object-oriented manner, we might put this pointer as the user data. I will just use global functions and a no pointer for this course. Now I can see that here I get a red underline indicating an error when assigning the function pointer. I've probably made a mistake with the function signature, so I follow in to see the exact one. I will copy these parameters here to double check them against our function. And Visual Studio is correct, and I have made a mistake here. And it is not the message type flag bits, but message type flags. And now that this is corrected, we need to return the creation info at the end of this function. Finally, we need to create the messenger. We can link the messenger to be created with the instance here. So if validation is enabled, we will call the getMessengerInfo. And now that I think about it, it is a local variable and needs to be created outside of the if scope. And we give its address to the pnext member of the instance createInfo. If we build and run our code now, you can see that we already have some messages written out. And if we make a mistake on purpose now, like setting this to a no pointer, you'll see this validation error that indicates what exactly has gone wrong. Let's correct that code back. This is how we enable the basic validation for instance creation. This is not the entirety of validation though. In the next videos, we will also need to create a separate debug messenger to handle all Vulkan messages and not just in the instance creation.